In this video, I will show how to graph a quadratic function by analyzing its vertex form. First, let's take a look and see that the equation is actually given to us in standard form. So to write it in vertex form, we have to complete the square. To complete the square, we have to first isolate the x squared plus bx term. So I'm going to factor out -1 from the first two terms to obtain this. And now to complete the square, I need to add something to these two terms to make it a perfect square. So half of 6 squared is 9. So by adding 9 inside of the parentheses, I get the perfect square. However, outside of the parentheses, I'm altogether adding -9. So to compensate for it, I have to add 9 again. So the same function written in vertex form looks like this: -x minus 3 squared plus 1. Now, most of the work is done. Now we just have to look at the parameters and identify the vertex first. So the coordinates of the vertex are 3, 1, and the stretch factor. Stretch factor here is -1. That means parabola opens down, and there is no stretch here. It's just going to be an upside standard parabola shape. So now we're ready to graph. We'll start with the vertex. Vertex is at 3, 1, and following the stretch factor, I go 1 unit out, 1 down, 2 units out, 4 down, 3 units out, 9 down, on either side, and now we have enough to graph this parabola. Now to find the y and x intercepts, we have to plug in 0. So we get -8, and to find the x-intercepts, we have to solve the following equation. So to solve it, we isolate the square term first, and then use the square root property. We find 2 x-intercepts. So the only y-intercept is 0, -8. The 2 intercepts we have are 2, 0, and 4, 0. So this is how you analyze quadratic function from its vertex form.